All right, there, video 2 for lesson 11.3, and we got Diani, sorry. So Diani is 1.8 meters tall and wants to be able to stand inside her new tent. Should she buy this tent? So we have a tent here. 3.4 cubic meters, has a square floor with 8.4 meter perimeter, right? So the idea here is that this square pyramid, right? We had a square down here, right, has a volume of 3.4 cubic meters. So there's the volume. The volume is 3.4. This square flooring have a perimeter of 8.4 meters. That's going to allow us to find the side length of the square, because perimeter for a square is 4 times the side length. So we take 8.4 equals 4 side lengths, divide by 4. We get an S value of 2.1. That is the edge of each side of this square, 2.1. Okay, so now we are going to find the volume, or use the volume formula of this to find the height. So the volume formula for a square pyramid is going to be 1/3 the area of the base times the height. Again, the area of the base is a square, that's S squared, that's 2.1 squared. And 2.1 squared is 4.41. So we're going to take the volume, which we know to be 3.4, and we're going to set it equal to 1/3 times the area of the base, which is 4.41, times the height, which we want to figure out, right? So if we take 1/3 of 4.41, so we have 3.4 equals, and 1/3 of 4.41 is a nice round 1.47, and then we divide by 1.47. And 3.4 divided by 1.47 gives you a height of roughly 2.31. or 2.3. And if we take a look here, the height of the tent, 2.3, is greater than 1.8, right? Which means that, yes, she will fit, so she should buy this tent. All right, next. Example 4. It says, a restaurant sells smoothies in 2 sizes. Which size is a better deal? So this is what we call unit pricing. So if you ever go to the grocery store, right, and you know how like they have, like, if you're buying peanut butter, right, they have different size peanut butters. If you look, typically the bigger the jar of peanut butter, the smaller the unit price, which means the better deal you're getting. However, a smaller jar of peanut butter costs $2, a larger jar costs $4. What do you want to spend? Do you want to spend 2 or 4? Is it worth getting the deal to spend more now or not? So again, that's all, you know, as consumers, the choices we have to make. Now this problem is not as straightforward though, because you do have to find the volume. And if you notice here, these measurements of 15 and 12, these are what we call the slant heights. To find the volume, what we're going to do here of this size smoothie, we need to actually find the height of these cones, right? And again, we're going to estimate these as cones. So this would be the radius, and I know the radius for this. The radius here is 5, because I'm assuming that this diameter is 10, right? Again, that's not a very good picture there. So we're going to assume that this is the diameter 10. So we're going to say the radius is 5. But then the height here that we need is this perpendicular height. We need that, right? Same thing here with the small smoothie. I'm going to assume the radius is 3.5, but then the height here, we need to find that height as well. Okay, so we haven't really talked about the slant height, so let me just draw a quick little cone up here. So here's a cone, right? Typically we call the slant height L. This would be your radius, and then this would be the height you have to find. So notice that, this is the height. Notice that when you draw that height in, you do create a right triangle. So we can use Pythagorean Theorem to find this height from the radius and the slant height. So this is just going to be a Pythagorean Theorem question. All right, so we got a lot of work to do because we have to do it twice. All right, so let's come back over here. So let's handle the large smoothie first. So this is the large. So we're going to do a squared plus b squared equals c squared. The slant height 15 is your c. So I'll do h squared plus 5 squared equals 15 squared. You're going to square each side individually. So h squared plus 25 equals 225. Subtract 25 on both sides. So h squared is 200. And then take the square root. And I'm going to leave that alone. That would actually simplify radically. I'm not going to worry about that. Let's just leave that alone because we're going to do the unit prices, so it doesn't really matter what this actual measurement is. Okay. So now, to find the volume of this cone, we're going to do volume equals 1/3 the area of the base times the height. Again, this is a cone, so the base is a circle, pi r squared h. Right, so volume equals 1/3 pi. The radius is 5, so times 5 squared, and then your height is the square root of 200. And you would type all this in at once, right? All of this. And we get a volume for the large cone, the upside down smoothie glass, of roughly 370.24 centimeters cubed. And then unit price is dollars per measurement. So to find that unit price, we're going to take the amount for a large smoothie, $5.89, and we're going to divide it by 370.24. So this will be dollars per centimeters cubed. And when you divide that, I got roughly 0.0159 dollars per centimeter cubed. And again, this doesn't really make sense, right? Because money is to 2 decimals, but that is the unit price there. Okay, and now let's move on. I'll do it in blue to the small smoothie, right? For the small smoothie, you can use Pythagorean Theorem. Let 12 be your C. So we're going to do h squared plus 3.5 squared equals 12 squared. That is h squared plus 12.25 equals 144. We're going to subtract 12.25 on both sides to get h squared equals 131.75. And we'll take the square root, and again, I'll just leave that alone because it's not a nice number. So h equals the square root of 131.75. So again, to find the volume formula, 1/3 pi times our radius squared times our height of 131.75 in a square root. When you multiply this big thing out, you get a number to 2 decimals of 147.24 centimeters cubed. So then I'm going to take it over here, and I'm going to take the dollar amount for a small, $3.49. I'm going to divide by 147.24 centimeters cubed. And when you do the division, you get $0.0237 per centimeter cubed. And the question says, which size is the better buy? And just as I mentioned before, typically your larger sizes are the better buy, so the large is the better buy. But again, it's a question of better buy versus how much money do you have right now, right? Do you really want a large? Yes, it costs more per centimeter cubed, but you're going to pay $6 for a large and $3.50 for a small. What do you want to pay right now? So, like I said, consumers, right? We always have decisions to make. All right, very good. And then, last but not least, is example 5. So we have a composite figure. So this word composite here means made up of different shapes, right? Multiple different shapes. So it says Caitlin is making a concrete animal sculpture. Each bag of concrete mix makes 0.6 feet cubed of concrete. How many bags of concrete mix does she need? So obviously, I don't know what the shape is. Could be like a, I don't know what this could be. A dog, bear. Anyway, but we need to find the volume of these 1, 2, 3, 4, 5, 6 pieces, right? 4 legs looking all the same, a rectangular prism body, and then a square pyramid face with nose. Okay, so let's do the square pyramid first. So the square pyramid is the yellow guy, right? So the volume of a square pyramid is 1/2 the area of the base times the height. This 20 inches is your height. The area of the base, because it's a square, is going to be s squared, which is 16 squared, which is going to be 256. And then we're going to go ahead and do volume equals 1/3 times 256 times the height, which is 20. And you get a nice number, I believe, of 1707. So that volume is 1707. And that would be in inches cubed. Okay, now we need to find the volume of the rectangular prism. So I'll do that right here. So for the rectangular prism, that's going to be volume equals area of the base times the height. Let's call the base, whatever, the bottom side, right? 20 by 18. So the base is going to be the bottom rectangle, 22 by 18. That is 396. So then to find the volume, we do 396 times the height, and I'll call 15 the height, right? Going vertically, so typically it's the height. And that's 5940 inches cubed. 5940. And then last but not least are the 4 cylinders. So I should have done it in different colors. I'll do a different color now. So for the 4 cylinders, we have the diameter of the base, 4 inches. So if the diameter is 4, that means your radius is 2 inches. And again, to find, and the height is 16. That's the vertical height. These are oblique cylinders, but who cares? We have the radius and we have the height. So to find the volume, remember it's area of the base times the height, but because it's a circle, pi r squared h. So volume equals pi times 2 squared times 16. And that's going to be 64 pi inches cubed. And again, I'm not going to round to the very end. So now here's what we need to do, right? So we need to find the total volume. So to find the volume total, we're going to add 1707 plus 5940 plus 4 times 64 pi. So this is going to be our answer in inches cubed. So we get 8451 inches cubed. And again, I rounded here. I don't think I'll be too far off. It's okay. But now, we have to convert this into feet cubed first. Now, I want to watch this carefully, right? Because a lot of you guys are having trouble with this. Yes, we all know that one foot is 12 inches. Sure. But you can't just use that as your conversion factor because we're in units cubed. So you have to do 1 foot cubed. And 1 foot cubed is going to be 12 inches by 12 inches by 12 inches. 12 cubed. So 1 cubic foot is actually equal to 1728 inches cubed. So again, that might be blowing some of your brains right now, right? The fact that, that's how you would do that. But that's the correct answer, right? That is the conversion factor we have to use. So now we're going to take this 8451 and divide it by 1728. We need to know how many cubic feet we are. So we're going to do 8451 divided by 1728. And again, we rounded. If you want to keep it out to more decimals, that's fine. But when you do this division, I get roughly 4.89, and that's feet cubed. So then I'm going to divide that 4.89 by 0.6 because each bag is able to satisfy 0.6 feet cubed, create 0.6 feet cubic, whatever volume of concrete. And when you divide that, you get 8.15. And of course, that would be number of bags. And of course, when you do this, you can't have 0.15 a bag. So when you're at the store, do you buy 8 or 9? If you only buy 8, you're short. So you must round this up to 9 bags. And that's how much concrete Caitlin must have to make this concrete sculpture. All right, thanks for watching, and we'll see you in class.